Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera. So we will continue discuss our hybridization that involve a multiple bond, and now our example is how to draw a multiple bond in cyanide ion, Cn minus. Alright, so first of all we need to draw a correct Lewis structure, because it is in the form of ion. It's supposed to be in a square bracket with a negative charge outside. Okay, as I mentioned previously, all the atoms that involve formation of multiple bond have to be hybrid, right? So in this case, both atoms, carbon and nitrogen, will undergo hybridization. Okay, so if you can see here, carbon, so the triple bond means 1 sigma bond, 2 pi bond. For carbon atom, we have 1 sigma bond plus 1 lone pair. So the shape is sp. The hybridization is sp. For nitrogen, it's also have 1 sigma bond plus 1 lone pair. So the hybridization also sp. This is step number 2. Because it is in a form of ion, there is an additional step because it is a negative. So we need to identify the formal charge for each atom to determine which atom brings the negative charge. So because of that, we calculate the formal charge for each. Let's say I calculate the formal charge for carbon. Carbon consists of 4 valence electron minus 2 lone pair minus half of 6. Become negative 1. So we know that negative charge come from carbon. If you want to check for nitrogen also can. Formal charge nitrogen 5 minus 2 minus half of 6, it become 0. So the carbon that involved in this hybridization is carbon ion, not carbon neutral atom. Alright, so the next step is to write the ground state, excited state and hybrid state. Because the carbon is in a form of negative charge, so we write the ground state for carbon negative ground state. If you draw for carbon, your answer will be wrong and you cannot get the result. Carbon have 4 valence electron. When it become negative, meaning that it accept another 1 more electron. So this is the shape. It have 5 valence electron. Because based on the Lewis structure, we need to keep 1 lone pair. So this is the excited state. We will rewrite the orbital diagram. And then for the hybridization, we need sp, so that we only blend these two orbitals together. So we have carbon hybrid or hybridization, sp, that consists of 1 lone pair and 1 electron, and we keep another 2 electron as 2p orbital. Okay, besides carbon, we also need to hybrid the nitrogen atom. Okay, because the nitrogen, the charge is 0, so we have and nitrogen also have 1 lone pair, so we need to keep the lone pair. And hybrid we only hybrid sp, so these two only. Okay, Alright, so we settle this part. Now we have to look at SP. The shape supposed to be linear, and this one also supposed to be linear. Now it's time for drawing the orbital overlapping. For carbon, it is SP. The shape is linear. This is SP. This is another SP orbital. It's represent carbon. It brings one electron and lone pair here. It will undergo overlapping with another SP orbital that represent nitrogen atom. Nitrogen have one lone pair and one single bond, and it will form a sigma bond. Okay, so for carbon, we have another 2p orbital. The 2p orbital supposed to be in a dumbbell shape. One 2p orbital. This is another 2p orbital. One electron, and we have another one, because nitrogen also have another 2p orbital. This is 2p and this is 2p. That brings 1, 2. Okay, now if you look at here, this will undergo overlapping with this one because it is parallel. Okay, for your final exam, you don't have to color the orbital. I color it, or I left because I want to show you the side of the orbital to make sure that it is parallel. And another one side, okay, this is another pi. So finally you can check, make sure that, I'm sorry, the carbon here is not carbon atom, but it is a carbon negative. So I have to correct this one also carbon negative, sorry. Okay, so because we already put the negative charge on the atom, so we don't have to put in a square bracket. Alright, so bear in your mind about this carbon, it is carbon negative, not carbon atom. Alright, so this is SP. Okay, so I think that's all. Thank you very much.